This is an overview of HyperionTransit, an application that I developed while working for Transmilenio, the transit agency in Bogota, Colombia. HyperionTransit is called HyperionTransit because Hyperion is the god of observation, and the whole purpose of the application is to give us a big picture of what's going on in our transit system. HyperionTransit basically is an application to visualize some of the data that we very commonly manage in transit agencies, such as GTFS files, origin destination matrices, assignment results of demand models, and this type of data, and visualize it in a way that can help us inform decisions such as the design of routes, the scheduling frequencies, and even the design of stations. So I'm going to first give just an overview of some of its capabilities, and then I will create further videos explaining exactly how to do certain types of analyses and explaining certain specific features of the tool. So the main page of the application is this interactive map. So as you can see, I'm using the example of Bogota. Just so you know, the data that is public is real, such as the routes and the schedules and the locations of the stations. But the data about passenger demand is not public, so it's actually randomized data. So what you can see here is there's a circle representing each station, and right now we're looking at the saturation of buses in stations. We can also look at the saturation of passengers in stations, and we can change the theme. Right now it's green if there's no saturation, it's orange if there is saturation, and the size of the circle is proportional to the demand that the station is facing. But we can change that so the size represents the capacity. We can look at how this changes over the course of the day. So we can animate every half hour of the day, and we can see very clearly how between the peak periods there's very little activity, very little saturation, but as we return to the evening peak, the saturation returns. So I'm going to put that back to the morning peak because it's a little more interesting to look at. So down on the bottom here, we can look at where the passengers are going and where they're coming from for a specific station. So right now I've selected Calle 100, which is one of the busiest attractions. So I'm going to click attractions, and I'm going to click spider here, and that's going to show us thematically where the passengers that get off at Calle 100 are coming from. So you can see one of the darkest lines here is from the terminal in the north of the city. Another one is the terminal to the west of the city on 80th Avenue. And we can filter these lines if we want to see fewer lines, just see the most important origins. We can filter down to only 15% of the lines and see the results that way. Sorry, let me go back to Calle 100. There we go. So these are the results for just the 15% most important origins. So we can also look at productions, trip productions, and you'll see, well, there aren't that many, and they're all going north. But that's because Calle 100 is a common destination. It's in the central business district for this time of day. We can also look at routes. So for example, if I pick the zonal system, which is the traditional bus system, I can filter by various things. I can filter by the origin zone that the route starts at. I can filter by where the route ends. I can filter by the company that operates the route, or service ID, which is the type of day. So whether it's Saturday, Sunday, or a weekday. So I'm going to filter by, let's do Sunday. And I can filter by certain attributes, certain performance metrics of the route. So I can look at, for example, the routes with the highest ridership. So again, I have a slider to filter the results by percentile. So I'm going to look at just the 10% of routes with the most ridership. So I'm going to go ahead and display those routes. And here we can see thematically the 10% most successful routes in terms of demand. The green routes here have the most demand, and the red routes have the least of the routes shown. And over here on the left, we have a legend showing the values of the themes. If we want to, we can include stops. So I just click stops, and it'll map again, but showing the actual stops of each route. So if we look at the BRT system, we can do something similar. We can actually just pick a few select routes here if there are a couple we want to study. And in this case, I'm going to select stations because I just want to see what stations they stop at. And so here we are. So for any of these visualizations, I can turn on or off a layer if it's not useful to me. So in this case, I'm going to turn off the origin-destination pair because that's just in the way. And you can see I can toggle, I can turn on and off the stations, turn on and off the routes. So another thing I can look at is route segments. So this takes into account the results of an assignment model. So over here, I'm just going to pick the route that I want to look at. So let's look at route B11 of the trunk system, the BRT system. And we can see, again, these are not real data. This is false data because the data is not public. But with our false data set, we can see that this route is very congested up until we reach about Cayenne, the station we were looking at before, where most passengers get off to go to work. And then after that, the route is practically empty. And this has obvious implications for the design of routes. Maybe we could design a route, reinforcement routes that just go to the central business district and turn around, so we don't waste service where there's no demand. Another thing we can look at is corridors. So this is looking at the total demand on a corridor over the total supply. Now this isn't always a good metric to look at because in public transportation, people take a specific bus that will take them to their destination. It's not, the total capacity is not as relevant as it is, for example, for private auto transportation. But it still can be a good indicator if some corridors are more congested than others. The last thing we can look at is origin-destination pairs. So for stations, we looked at attractions and productions. Here we can look at similar desire lines, but between different corridors. So I'm going to, for example, choose 3 different corridors, corridor B, E, and let's say G. And I'm only going to look at that one direction. And again, I can filter by percentile. And I can go ahead and display desire lines. So you can see in this example, there's not many. Let me take off the corridor saturation. In this case, it's not showing very many lines. So I'm going to increase the percentile and show 30% of the lines. There we go. And actually, I might look at the other direction. Let's look at G, E, and B. And I'll do the same thing. So here we can see the 30% most important origin-destination pairs between these 3 corridors. And this pretty obviously indicates where one might have an express route stop. So for example, if we zoom in a little bit here, these stations on the corridor don't have any desire lines in the top 30%. So it's probably a good idea for any express routes to skip over these stations and focus on serving the stations that do receive lots of demand, whether it be boardings or alightings. So I have another feature in this tool that allows us to draw proposed routes. So here I can just sketch out a route real quick following this corridor. Let's just have it stop there. If I want to, I can change the color of that route so it stands out a little bit from the other things I'm visualizing. And then I can draw some proposed stops. So just as I mentioned, I'm going to look to put stops where we have lots of desire lines. And I'm going to skip over the stops where we have little demand. So I can go ahead and get rid of, well, remove these from the map temporarily. And so the other useful thing in this application is, as well as showing things on the map, I can actually produce graphs automatically. So for each station, it produces a bullet graph which shows 3 types of saturation. Saturation of passengers in turnstiles, passengers in loading bays, and saturation of buses in the stations. And it shows these over the course of the day. So you can see as I animate the graph, changes according to the saturation at that particular hour of the day. And this vertical bar shows the maximum saturation that occurs. So the theme on these graphs matches the themes on the map, and you can easily see sort of what types of saturation a certain station is facing, and that will indicate certain interventions. So in the second graphic, we have the station saturation timeline. So this shows us how the current selected type of saturation varies over the course of the day. So right now we're looking at passengers and turnstiles. Obviously, we have a peak demand in the morning around 6:30, and another peak when people are returning from work around 7 p.m. And up here in the red line, we have the capacity of the station. So in this particular example, the station is not saturated. So we can also look at the saturation of a route over the course of its trajectory. So in this case, you might recall that the route showed up very red for the first about 2/3 of its path, and that's also shown here in this graphic where we have demand exceeding capacity for most of the route, but then demand falling well below capacity in the northern part of the route. In this graphic, it shows us the boardings in orange and the vacancies on the buses that arrive at the station for each of the routes that serve the station. So, for example, if we have a station that's saturated with buses, we might actually remove a route from that station to reduce the saturation of buses. But in order to do that, we have to pick a route that is not actually serving many people. So in this graphic, we can find a route that has few boardings and maybe lots of vacancies. Here we can view the saturation of a specific corridor. So we can see inbound and outbound saturation over the course of the corridor. And the final graphic here is a simple table which creates it's a list of recommendations of either policies or infrastructure interventions to apply to the selected station. So this table is created based on the results of the saturation analysis that the application performs on the back end. So all of these graphics can be seen in a larger format on another tab. And I also have a tab that shows the engineering drawings of the stations. So if we decide, for example, that we want to add a platform to a station, well, we can see how the station is currently designed. So we can see the engineering drawings here, we can see the dimensions, and we can see if there's space to add another platform, or if we can adapt one of the platforms to serve larger buses, for example. And then we have another tab here with the tables that the application uses. So there's a table for stations, and we can simply filter the table. We can sort the table by levels of saturation to quickly find the stations that are the most saturated. And we can also look at route segments with the modeling results. We can look at corridor segments with aggregated results, and we can look at origin destination pairs. Again, this is just a way to quickly identify some of the worst cases. Now, the last tab will include links to this tutorial and the other tutorials with more specific instructions for specific types of analyses. And if you scroll down, you'll see documentation on the application that explains in a little more detail how each feature works. So thanks for listening, and as you play around with the tool, take a look at some of the other tutorials to get a better idea of exactly how you can take advantage of some of its features.